Model equations concretely, but I think whichever way you happen to use, it helps in your understanding of what to do, because you certainly don't want to approach this from trying to memorize how to solve things or memorize the approach. It's better to understand. Algebra tiles are one thing you could use. So I put that in here just to say use algebra tiles to model this, but I do want to show you this one first, because I happen to like this one better because I think it's more intuitive and for you to understand. We're going to model each of these equations. I'm going to write this up here. Okay, you can write it wherever you want, but I'm going to make a model with blocks and balloons up here, and then I can show you algebra tiles later on some other time. Okay. This first equation here, x plus 3 equals negative 1. I want to show you on here how to do this. First of all, I got to create this on here. What this model is, it's like a teeter-totter here. What was the equation we had there? Let's say we have x, so we have 1, x plus 3 equals 5. Isn't that the grade 2 question I gave you? Something like that. X plus 3 equals 5. How you can model this is this box is meant to be x, but we don't really know how big it is. They show it as that size, but it could be whatever size we want. But what we're saying here is x plus 3 of those things, 3 of those blocks, is 5 of these. Okay? What's going to happen as soon as I put 5 on here, the fifth one? What's going to happen as soon as I plunk this one on here? It's going to equal out, right? Because it says those are equal. That's what that sign means. In elementary school, I think you learn, or you sort of think that sign just means, and now I will tell you the answer, right? That's not what that symbol means. In elementary school, it kind of does. That's how you use it. You say, here's the question, here's the answer, and I think in elementary school, you kind of just start to think that means, and now I'll tell you the answer. It doesn't mean that. It means whatever's on both sides are the same. Okay? If you want to solve that in your head, the way you do that in grade 2 is kind of that picture there. Maybe don't picture a balance like that, but you picture something plus 3 of them is 5 of them. So how much does that have to be? 2. You're kind of just taking these 3 away, right? These things? You're taking away 3 of these. If I just take away 1 from one side, what happens to the balance? It gets unequal. But what about if I took the same amount away from both sides? If I took 1 off of each side, stays equal. Or if I take another one off of each side, or if I take another one off of each side, if I take the same thing off each side, it stays balanced. That's going to be our strategy for solving equations, is as long as you do the same thing to each side, it stays balanced, because you have an x and you have 2 there. That's going to be our approach here. Okay? On that page, I would like you to somewhere, either down here or here, draw a balance like that. It doesn't have to be complicated. All it has to be is like this. Maybe here's 2 sides. You could have something and then the little pivot place in the middle like that. We're going to use a block that's not that shape. How about if I just draw it myself? Okay, there's an x. Now, actually, this is not the equation that I had here because this is a negative 1. Let's change that one for a second here to x plus 3 equals, what did it have, 5? Can we use the one that we had there? X plus 3 is 5. And we need a bunch of these here. We need 3 of these, and we need 5 of them on this side. I think this helps you work concretely with this. This equation says x plus 3 equals 5. Our approach to this is going to be, what did we do to both sides here? We're going to write it down. Let's write it with words here first. What did we do to both sides to get x by itself? In the end, we had x equals what? We had this is equal to that. In the end, we just had x is equal to, how much was it equal to? 2? What did we do to both sides of the balance to get it that way? What did I do? I took in total, how many did I take off each side? 3, right? I'm going to write in words here. Subtract 3 from each side. Okay, I subtracted 3 from each side, and that gets you to your answer here. And you get x equals 2. What if we look at that second one there? 5 equals x minus 7. I'm going to do a similar one here, except I'm going to make this only 3 here, just to keep the number smaller so I can model it on that thing. I don't think I can use such big numbers. It's possible. Let me try. Actually, let me try using the 7 first. Let's first of all do this. Grab a picture of that in case we want it after. Okay, that's the solution in the end, that thing. For the second one here, we want to model it. What was it again now? Let's write it down here. Let's make some space first. You can write it on your space on your page there, but I'm just going to make some blank space instead. It was, what did I say, 5 equals x. Well, it said minus 7. Let's check if it'll allow us to put that in. First of all here. I want it to say 5 on this side, so what do I put in here for each of these boxes? You notice how it allows you to put an x on both sides? I have a 5 here. What do I put in here? Do I put a 1? How many x's do I have on the left side of your equation? 0. You could either put 0 or just leave it blank. What about this side? How many x's do I have on this side if it just says x? How many x's if it just says x? 1. So you could put a 1 there. And then what was the other thing we had here? Yeah, so I don't think this well, let's see if this allows me to change it to a minus there. You can either do this, or I could have done plus negative 7. Okay? You could do either way. Plus negative 7. Okay, now it's going to write it like that. Do you notice how I put in plus negative 7, but it just changed it to x take away 7? Because that's the simplest way to write it. How do you model this? What do I need on each side? What do I need on this side of the thing?
5.
I need 5 of which? The blocks, these 1 blocks. Now, of course, it's going to be weighed down for a second here. I got 5 of them. What do we need on the other side? I got an x. Now, the thing is, subtracting 7, it's hard to put blocks there to represent subtracting, because subtracting something makes something lighter, right? The way you're going to model subtraction or negatives on here, this is like plus negative 7. Negative 7 makes it less than x, and the only way to do that is to tie helium balloons on here. If you put a helium balloon on there, it's pulling up. The weight of this thing is pulling down, right? The blue ones weigh the thing down. If you have minus 7, it's taking away from the weight of the x, right? So you need 7 of these. 4, 5, 6. And I put the last one, what's going to happen again? It's going to be evened out, right? So you have the weight of the x plus, but take away 7, right? This might be a huge number in here, you don't know, right? If I want to solve this, how can I solve this? Well, before we took away stuff from both sides, there were blocks on each side to take away, right? Here I want the x to be by itself. If I want to take something away, if I start taking away these balloons, what's the problem over here? Remember, can I just start taking stuff away and, like from one side, can I just take something away? No, because it doesn't keep it equal. I got to do the same thing to both sides. If I start taking away balloons here, what's the problem with the other side? I don't have any balloons to take away, right? I can do something that's the opposite of taking away the balloons. Taking away these negatives. What's the opposite of taking away those negatives? What's the same as taking away those negatives? I could add this, right? Because if I added one of these to both sides, what would this do to one of those balloons? Pop it. I wish it would, but I think it's just going to balance it out, right? What I could do is I could add this to both sides, right? I could add this to both sides. As long as I do that, right, I counteract the balloons. Okay, if I add, how many am I adding to each side? It's kind of tedious when you do this, right? But it won't let me add any more to that. What happened there? Well, I guess you can't add more than 10 to this thing. Okay? Doesn't like it. If I could keep going with this, what's going to happen? If I could add 2 more blocks here, right? If I could add 2 more blocks here, how many would I have over here? I'd have 12 over here, right? Because I had to add a total of 7. What would those 7 things do to these 7 things? What did you say? These would, because if I take away a block and a balloon, which I can't do at the same time, but if I do that, you notice how that's equal, right? Take away a block and a balloon. If I take away a block and a balloon here, it stays equal. Okay? Oops. If I don't happen to do that, one more. Okay, if I could add 2 more of these, this thing won't let me go numbers bigger than 10, but if I could add 2 more of those, I'd have 12 and I'd have the x there. What you're going to do here is you're going to add 7 to both sides. If I add 7 to both sides, I get just an x on this side, and what did I have on the other side? What did we say we had on the left side? Not 0. After you add 7 to both sides, if you add 7 to both sides, it's going to it's going to get rid of those things, right? The way you're going to write this is you're going to do this. You're probably not going to write it in with words very long, but I do want to emphasize you're doing that. What you're going to do is you're going to write plus 7 right underneath the minus 7. Okay? Because what happens to those things together?
Makes it 0.
This cancels out. This ends up being 0. Okay? This cancels out. That counteracts. One of the blocks and one of the balloons add up to 0. That's like having 0 there. You just have x, and then what do you have on this side? What does this add up to? Oh, okay, no, it's supposed to be this. Sorry, it does add up to -2, but I messed up. That's maybe why you're confused. That should be add, because if I'm adding 7 there, I got to add 7 there. What is that? Then it's 12, right? That's what the solution is to that. What am I doing here? This is 12. Writing the wrong thing all over the place. Okay? You could write it with words, or you could write it with symbols like this, plus 7, plus 7. Just put a plus 7 on both sides. Just like the one up here, you could have said when you have x plus 3 equals 5, you could have said, I need to take away 3 from both sides. What would you have left? This cancels that out. You just have 2. I know you can see what the answer is without doing this, but this is going to be the key to solving equations for the next 3 or 4 years in your math courses, is the idea that you can do the same thing to both sides and it keeps it balanced. Okay, it keeps it balanced if you do the same thing to both sides. Let's see if we can do this without the balance, and then we'll check it on the computer thing. What about if it was multiplication? 3x equals 6. Let's make one where it's actually, let's put a negative in there. 3x equals -6. 3x equals -6. What does this mean on this side? It's 3 times x. Okay? How do you model that on this thing here? How do you model 3x minus 6 here? I'm going to put it in 3x, and I'm going to put -6 on the other side. How do you model that? How do you represent that with these balloons and blocks? What do you think? This side's easy. What do we need on this side? I need 3 of these, right? 1, 2, 3. What happened there when I put the blocks? What happened?
Minus the weight.
Yeah, why did it go up like that? It knows something you don't yet.
They're worth -6.
They're worth -6. Inside there's actually balloons, right? Like there's something that weighs less than 0, which I know in reality is not possible. But when you find the solution's actually going to be a negative number, right? It's saying 3 of these is equal to 6 balloons. If you draw it like this, is pretty obvious what each of those has to be equal to. What does each one of those have to be equal to? 2 of them, right? I can't solve this one by adding things or subtracting things from both sides, but I can solve this by doing something to each side. What can I do? If I have 3 of them and it's equal to 6, I could cut each side into 3 pieces, right? I could divide each side by 3. If I divide this side by 3, what do I have? I got one of them. If I divide this side by 3, what do I have? 2 of them, right? On your page here, you can model that like this, right? You have 3 of these things. 3 x's is, this is going to take a long time here, right? Draw your little things. You're going to have to be able to model them. You're not going to model them for very long if you don't like drawing balloons and blocks. But when you are modeling one of these things, that's equal to 2 of them, right? What are we really doing on both sides? If we have 3x equals negative 6, we are dividing each side by 3. Divide each side by 3. If you divide each side by 3, you get 1x is equal to negative 2. If you want to see how you're going to write it without writing the words here, if you start with 3x equals negative 6, you can just say I need to divide this by 3. Divide this by 3. If you divide each side by 3, what do you get on, what do those 2 operations do to each other? Times 3, divide by 3. If you times 3, then divide by 3, what do you get? If you take any number, times by 3, then divide by 3, what do you get? Just the number you started with, right? You just have an x there. This thing's all by itself here. Okay, that thing's by itself. This cancels out. That stuff cancels out. That's why you divide both sides by 3 and you get negative 2. If you have one that involves division, okay, a one-step equation involving division. If you have x divided by negative 4 equals 8, that one's not going to work on the on that website. If you have x divided by negative 4, this is tricky because that would be hard to represent on that site anyways, dividing by negative 4. What can I do to both sides? If this thing says x divided by negative 4, x divided by negative 4. Is that you, Kyle? Red in the face, is that you? Is it off? Oh, good. If you have an equation that involves this, if you have an equation that involves dividing by something, let's look at what we did here. When we had an equation that involved adding, okay, that equation involved adding. It said a number plus 3. What operation did we do to solve that? You did the opposite of adding 3, which was subtracting 3. You do the opposite operation to both sides. When we had an equation that involved subtracting 7, what did we do to both sides? You added 7 to both sides. That's the opposite, right? When we had an equation that was involving multiplying by 3, what did we do to both sides? Divide by 3 on both sides. Do the opposite. So when we have an equation that involves dividing by negative 4 on both sides, what's the opposite of dividing by 4 on both sides? Multiplying by negative 4 on both sides, right? Multiply by negative 4 on both sides. If you multiply by negative 4 on both sides, what are you going to be left with on this side? I'll write it over here again. X divided by negative 4 equals that. If I was to take, I'm going to put brackets around it and say times negative 4. Put brackets around it and put times negative 4, and put brackets around this and just put a negative 4 beside it. That means multiplying. I want us to not use I really want us to stop using the multiplying sign. Why do you think that is when we're working with equations? Why is it a good idea to stop using the multiplying sign? You can think it's an x and you're going to get mixed up, right? Use brackets instead like that. What happens over here when you have divided by negative 4, but then times negative 4? What do those two things do to each other? If you divide something by a number and then times it by the same number, what do you get? Pick any number you like 31. Let's say I times it by 2 and then divide it by 2. What am I going to get? You're going to get the number you started with. These cancel each other out. You don't even need them there, right? These cancel each other out. You're just going to have what left on the left side of that equation. This is the left side. This is the right side. What's on the left side after you do that? Just x, right? Just an x. What's left on the right side? 8 times negative 4, which is negative 32. That's the solution. Okay? Do you need an instant replay of all that? Okay, let's undo this until we can't undo it anymore. Okay, if you go back to what you started with there, why did I choose to multiply both sides by, that's a lot of undoing. Why did I choose to multiply both sides by negative 4? Why was it, number one, why was it negative 4? And number two, why was it multiplying that I chose to do? This involves division. So I'm going to use multiplication to isolate the x. What you're doing is you're trying to get this by itself. Do you know what the word isolate means? If you isolate something, what are you doing? Yeah, you're getting it by itself. We're getting it away from everything else. We're going to try and isolate the x, which means getting it by itself there. The way you're going to do that is to get rid of the other operations that are there. If the operation that's there is divide by negative 4, you times by negative 4 to get rid of that operation. But if you do it to one side, what do you have to do to the other side? It's exactly the same thing, or it doesn't stay equal, right? If I don't do the same thing to both sides, it doesn't remain equal. That's our approach. Do the same thing to both sides to isolate the variable. Okay? That's your bottom line here. Okay, do the opposite operation. I'm going to say use opposite operations. Okay, to isolate the variable. Okay, you must do the same thing to both sides. You should likely write this down somewhere. Unless you're going to look back at it on YouTube. Okay, can you notice that there's examples here? These don't necessarily follow the textbook. Some of them do, some don't. I'm going to do one of them with you. I think you should do the blocks and balloons thing. If we have this equation right here, we have 1x. There's your x. How do you represent this? How do you represent that minus 2? 2 balloons. If you want to make them red, you can, right? If you want at this point to save some time, instead of using 2 balloons that have a negative 1 inside, what might we do to make it a bit easier? One big balloon that says negative 2, just to save us some time here. And then on the other side, what do we have? We have one big, even huger balloon that isn't even round, but that has negative 5 in it. That's what I want you to do on the first balance. The second balance, what I want you to do is showing how do you start to isolate the x. So I want you to redraw what you have on the first balance. But how are we going to get rid of what's on the side with the x? How are we going to isolate this x? What are we going to do to both sides? What are we going to do to both sides? How do you get rid of this balloon here? Well, it says negative 2. What can you do to counteract that? You can add 2. What I would do is put a block here that had 2 in it. And I'd put a block here that had 2 in it. And then you put what's left after that. What's left after that? You just have 3 over here. Is it a balloon or is it a block? You just have x over here, right? Because we got rid of it. This stuff cancels out, right? The point of this is that cancels out. And then what do you have left on the other side? Is it a balloon or a block? A balloon. What did you say? A block? Block or a balloon? You got negative 5 plus 2? It's negative 3, exactly. Okay? The solution to that is x equals -3. You need to draw a sequence of diagrams. These are the three. What you have at the start, what you add, subtract, or whatever you do to both sides, and then what you have in the end. Okay? It's going to be hard to represent these with a sequence because it's hard to show what you're doing here. What you can do for this is you can say, because I'll do this one for you here. We have 5 of these, right? If you want, you can put one big huge block that says 5x. And you can put one big huge block that says 10 here. What I want you to do in the center here to show what you're doing is splitting this up, dividing both sides by 5. So you have 5 individual blocks, right? You have x. How many of these do we have? We have 5 of them, right? So here's my 5. And what do I do on the other side then? If I'm going to divide this by 5, I got to divide this by 5. How many am I going to have here? I need 2, 2, 2, 2, and 2, right? Show how you're going to split it up. So what is x equal to here? X is all by itself there. It's going to be equal to 2, right? What have I done on both sides here? I've divided both sides by what? Divide both sides by 5. Finish both those sequence of diagrams. Okay? And then do these by drawing a sequence of diagrams. I understand fully well that you can tell me what the solution is to this. I'm pretty confident you can each say, I realize it's 6. On purpose, I've picked things where you can see what they are. Don't hand this in by just saying x is 6. I get it. You need to do this. Use blocks, balloons. Draw a sequence of diagrams. They can be simple, just little. They don't have to look like much. Like that, you need 3 little diagrams here. Okay? What it is at the start, what you're going to do to both sides, and what it is at the end. Okay? Can you get going on that, please? I would say if you, at the very least, before you left, or by next time, finish this. I'm telling you that I'm gonna come and look at your work next time, or even before you go today. If all it says for this is x equals -2, I'm going to give it back to you and ask you to do it again. You got to represent it with the concrete materials, concrete objects. Okay? Does everybody understand that? I'm pretty confident that half of you, all you have here right now is x equals -2 or something like that. Go back and draw the balances. You got to draw the balances, okay?